Hello everyone, welcome to another video of mine. In this video, we'll be looking at the formation of Earth. From the time of the formation of the solar system, we're not looking at the formation of the solar system, just the formation of the Earth from the time it started forming to the time it was formed and to the time of the creation of the first human, or I should say, the end of the dinosaurs. Probably the early humans were not born right after the death of the dinosaurs. There might have been some animals, like mammoths and mammals, which came. The extincted mammals still exist today. Were a kind of mammal, and some kinds of mammal existed at that time, and they went extinct, and then it came to the age of humans. We're not talking about the age of humans, just from now on till the end, like exactly till the beginning of the age of humans. So let us begin. The name, our planet, is the third planet from the sun. The name Earth, which we give it, we call it like that, is a Germanic word, which actually means the ground. And we have been calling Earth this way, and it's been like 1,000 years. It's like this name stuck on this planet around 1,000 years ago. And actually, as I said, this word is Germanic, and Earth is an exception, was an exception when it was getting named. Because all the planets in our solar system, or all the planets outside our solar system, they were named something else than a natural object which actually exists. The planets outside our solar system are usually letters and numbers, or the name of the telescope with a number given to them. But planets in our solar system, all of them, there are 8 planets in our solar system, 7 of them were named after Roman and Greek god. And the one which is not named after Roman and Greek god is our own Earth. It's an exception. When the solar system settled in place, meaning that it was formed, like the sun was formed, our planets started getting advantages. They started gathering materials around themselves. Usually first there's the core, then there's the mantle, then there's the crust. And then by the gravity they generated, they can gather an amount of gas around them. Like Jupiter, the biggest planet in our solar system, it actually had a lot of gravity because it gathered a lot of gas around it. And it actually had the advantage because it was the first planet to form. But we're talking about Earth today. So planets usually form when giant rocks inside a sun's star's protoplanetary disk, a disk of materials around a star, which is usually used up to build. It's usually formed from that stuff. It's full of chunks of rocks which crash together and stick together. They get bigger. They generate the force of gravity. They draw more materials toward themselves. And this process goes on and goes on until they're perfectly smooth and round. Not exactly perfectly, like our own Earth has up and down, mountains, valleys, everything. That you probably cannot find a perfect sphere in space. But it somehow forms a perfect sphere, and actually this sphere will become the planet. First it's a dwarf planet, a small type of a planet, and then it gets bigger, a planet. And actually, if it has enough gravity, it will gather gas around itself, which is really cool. And our Earth, surprisingly, was formed the same way. So now, let's see how did really the Earth form. And that's kind of a subject to really think on, but we have some theory. And this is the most important one and the most accepted one. So first, there was the core, which formed by crashing rocks, meteorites, which crashed together, stuck together, and made this core. And the young planet was constantly bombarded by more asteroids, which means that it was really hot. And actually, for me telling you, like if you were to ask me, I'd tell you that those were adding to the planet's mass. But still, there was no solid surface for the young planet. Let's just forget the Earth we have today, as I said. And let's just imagine the Earth at that time. And, it will never be something like this. There is never something that I can stand on, or there will be never a blue sky or even me, or even any living organism, plants, rocks, buildings, rockets, aeroplanes, cars, nothing, roads, not even a rock to put your feet on. So you will just go down because it was made of a huge ocean of lava. And I'm telling you, it was way closer to the sun than it is now. It was like probably very closer to the sun. And that's why its temperature was tremendously high. And there will be something that will happen right away that will increase the temperature, sadly. The crash of the planet Theia onto our Earth. The young Earth, as it was bombarded by asteroids, suddenly a giant Mars-sized planet in the making called Theia crashed with our Earth. It ripped off a part of Earth's mantle, and those mantle, which were molten, they were lava, started spinning around the Earth. And as time passed by, so since they were molten, they stuck together to form a planet, around our own Earth. It was not a planet, it was a moon. It was our own moon. And so now we can know that the thing that helped make our moon was actually the materials used in our moon are mostly from the Earth. Yeah. And so Earth was also molten at that time. But we're not talking about the moon today. Okay, a moon was molten at that time, but we're not talking about it. Let's go back to see how it's doing it. How's Earth doing after that crash? Well, Earth has fallen into a furious rotation around itself. Right now, like at this current second, how long does it take for a day to last? 24 hours. So now, and let me ask you, can you guess how long did it took to spin, for the Earth to spin once around itself at that time? 6 hours. That's not much. That means I could only stay awake if the Earth was like this at that time, at that close distance to the star. And let's see, we had found a way to stay alive on it, and there were no bombarded asteroids to destroy us. Like, it will take 3 days for me to stay awake and 3 days for me to 3 hours for me to sleep. That will not be much for me to sleep. Anyways, we have to get used to the condition. But now it's 24 hours. I can sleep for 12 hours and stay awake for 12 hours. And this is not exactly mine. I can stay awake for like 14 hours and sleep for 10 hours. So now, let me just tell you about the next subject we're going to talk about the formation of our Earth. By the time the Earth slowed down after that tremendous crash, it has already passed millions of years, and the Sun's protoplanetary disk has been used up for building up other planets and their moons. So now let me turn on the lights. It's getting dark. Very good. So now let me tell you that actually after that there were no more asteroids, not much of them, to hit our planet. So the temperature, like, let me tell you that with every hit the temperature gets risen up. So now the Earth could finally have some cool down, because there were less tremendous crashes. And finally, Earth had a solid crust, yes, but there were still volcanic eruptions all over the planet, but there were still some big comet crashes, which were very good. Yes, let me tell you, those crashes have formed the water we drink, we use, we see, and we see in the oceans. Like, all the water have come from asteroids made of ice. Do you know where they came from? From the depths of space, or probably from the territories of Pluto or Mars. And now these comets brought water and glory to our atmosphere. Those water evaporated, went up to the surface, then rained down again as rainfall, and then it was just turning into the planet we know today. Alright everyone, now we come upon life, the first life on Earth. Early microbes started forming on our Earth about 33.7 billion years ago. And after that, let me just tell you, here's a cool fact. Humans didn't just appear on Earth at a specific time. They evolved from other creatures to find their structure. But some religions are against that. We don't have anything to do with religion here. Then, after that, the photosynthesis organism formed about 3 to 2 billion years ago. And those things brought oxygen to our Earth using the sun and using the sun rays. And actually that oxygen, something happened that the whole Earth turned into a frozen ball for a few million years. And then when it unfroze, an ozone layer had formed. Over time, the ozone layer of our planet formed. The ozone layer is the layer that protects the planet from deadly radiation sent by our sun. If the ozone layer wasn't there, we would have been roasted and would have been a great food for our sun, for our mother. I don't know why it wants to eat us. Okay, so now after that the photosynthesis happens and the ozone layer formed. It was too thin for any life to exist outside of water. Water was actually a protection from sun's ray, but still, because it was too thin, too much radiations could pass through, so it was dangerous for us to live there, for animals or any kind of life on Earth to live there. And then over time it became sicker, but before it became sick, as it was sick, the age of fish happens, when hundreds of kinds of fish formed underwater. And then some of those fish, after this ozone layer got sicker, even got close to the surface more and more. And actually the first creatures to live on the surface, or the first living thing to actually live on our Earth's surface after the ozone layer had thickened, were plants and fungi. Plants could do photosynthesis and fungi were just reproduction things. And actually, after those things, the first amphibious amphibious took the move to Earth as the first vertebrae on the ground. And after that comes the age of dinosaurs.